Hello and welcome to this show. This show is especially for one person who very kindly commented on my maths videos and my channel in general. That one person was lizz1331 or 1331. Okay, in fact her name is coming up now. Oh, there it is, you see, that's her channel, and a link to her channel will be in the crotch bar, which is doing here, right. I don't know my left from my right, I really don't. Right, now she gave us a fantastic reference here, very kind of her. Now she was wondering if I could do a video about integers, and hey presto, here it is. Okay, so let's start off with discussing integers before we move on to the mathematics of them. Okay, what is an integer? An integer is a full number, basically. Okay, a full number. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right up until 999,999,000 and 999 if you want. Now the same applies going in the other direction, going into like a negative equity here. Your negative integers, again, -1, -2, -3, -4, -5, -6, -7, -8, -9, right up until negative 999,999,999, and even further than that. Okay, basically any full number is an integer, and integers can be negative and they can be positive. Okay, right. Oh, just a second. Right. It's Tony the Tiger here. Is that a tiger? I think it is. Just wanted to say thank you very much indeed, lizz1331, for your very kind comments about Stunning Lad 1. Yee! This is a serious show, okay? There's people here tuning in wanting to know about integers. They're not interested in stuffed toys. Oh, yeah. Okay. Right, okay, that's enough nonsense. There's been too much silly behaviour in this show so far. Right, what Tony the Tiger? I think it's a tiger. Is that a lion? It looks actually more like a lion, doesn't it? Is that a lion cub? I think it is a lion cub. Right. Right, well, what he said to me was, can you show an integer as a fraction to make life easier? Well, we certainly can, but before we get into that, I just want to explain what isn't an integer. Any decimal figure behind the decimal point is not an integer, okay? So, it doesn't matter what it is, if it's behind the decimal point, it's not an integer. Same applies to fractions. If the denominator is bigger than the numerator, it's not an integer, okay? So any proper fraction will not be an integer, and any decimal figure behind the decimal point will not and cannot be shown as an integer. However, improper fractions can be shown as integers. 16/3. Okay, notice improper fraction means that the numerator, the bit at the top there, is larger than the denominator. Okay, so that can be shown as an integer, and that's a simple case of putting 3 into 16, and what do you get? 3 goes into 16 5 times, because 3 times 5 is 15, and that would leave you with a remainder there of a third. Okay, so 16 over 3 can be shown as an integer because it is 5. However, it's 5 and 1/3. So therefore, if you're showing that as an integer, 16 over 3, we're not interested in the fragment of a unit. We're only interested in the integer figure, which is 5. So that improper fraction, or any improper fraction, can be turned into an integer simply by dividing the denominator into the numerator. Right, okay, so we'll move on to some sums now. Now, lizz1331 was asking especially about dividing integers. Now, how is this done? It's done quite simply. Right, let's just take some examples here, okay? Right, start off with minus 48 divided by, negative 48, I always call it minus, negative 48 divided by negative 4, okay, divided by positive 6. Now, it looks really complicated, doesn't it? Until you learn one trick. Now, this one trick is knowing that any integer can be turned into an improper fraction. Okay, doesn't matter how large it is, and this is how it's done. So we're starting off with negative 48. We put that over 1. Okay, that is what negative 48 looks like as a fraction. Now, if we are dividing, we can change dividing into multiplying, okay, because that you can get to the same answer with multiplying, so there's no need to divide in an instance like this. Right, so we're dividing negative 4. Now, when we've changed it to multiplying, it's got to switch over. All right. So instead of being 4 over 1 or negative 4 over 1, it becomes negative 1 over 4. Okay, we're flipping the denominator and the numerator over. And it's also asking us to divide that by 6. Okay, so let's see if you can tell me how that should look as a fraction. That's right. It looks like that because although it is 6 over 1, we're multiplying it, so you've got to flip over the numerator and denominator. If you don't, you get the wrong answer, I'm afraid. So that is how it's looking so far. Negative 48 divided by negative 4 divided by negative 6. And we've changed it around. The first part of the equation stays the same, negative 48 over 1. We don't have to flip anything over there. We're only flipping the next parts. So that is multiplied by negative 1 over 4. And then that is multiplied by 1 over 6. And then it's just a simple case of doing the maths. What is 48? Let's just forget about the negatives for the time being. What is 48 times 1? 48. Okay, what is 48 times 1? Well, it's 48, isn't it? Because 1 times anything is going to be that, isn't it? That makes sense. So we already know 48 is going to be in the top line there. So negative 48 times negative 1 times 1. Now, however, we have got a negative being multiplied by a negative here. Okay? Now, when a negative is multiplied by a negative, it becomes a positive. So we now know that negative 48 times negative 1 is positive 48. And positive 48 times 1 is, surprise, surprise, 48. Now the bit at the bottom we've got to do now. 1 times 4 is 4. 4 times 6 is 24. Then we're saying, see, we've got an improper fraction there. 48 is over 24. So we put the 24 into 48. It goes in twice. And hey presto, the answer to that sum is plain and simply 2. I hope you get that. So negative 48 divided by negative 4 divided by 6 is 2. Just hope I haven't started off with a really complicated one there. Right, okay, let's flip the page over and go to another problem. And here is the next problem. Okay, this time we're not going to be showing them as improper fractions. This is what we are being asked here. Okay, simplify this slightly. Negative 6 divided by 3. Now this can be worked out in our heads without having to monkey around with improper fractions. Right. Okay, negative 6 divided by 3 is going to be negative 2, isn't it? You know, because 3 negative 2's go into negative 6. Now remember, when you're dividing a negative by a positive, it will show as a negative, okay? It's only when you're dividing a negative by a negative that it will show as a negative. There is a golden rule, right? If the number's odd, okay, if you're asked to divide any odd number of negatives, okay, it will have to show, the final answer will have to show as a negative, all right? If it's even, if your equation's got an even amount of negative numbers being divided, then it will show as a positive. Okay, so that's the golden rule. Negative 17 divided by negative 4. Now you may ask yourself, why am I monkeying around with all these negative integers? Because, well, let's face it, standard integers are quite easy to work out, you know. I think we're slightly above that level, you know. Right, so do you remember the golden rule here? Negative 17 divided by negative 4. Is that going to show as a positive or a negative? You've got a negative being divided by a negative. It is going to show as a positive. And we'll go back to our improper fractions again. Okay. Now, what are we doing here? Where does the 4 go? Where does the 1 go? You're absolutely correct. Right? Then it's 17. Just forget about the negatives just now. What's 17 times 1? 17, right? What's 1 times 4? Oh, I think we all know that one. Forgive my writing. Now, we don't have to add any negative there because, don't forget, we're dividing a negative by a negative. And that's the same rule when you're multiplying a negative by a negative. Okay? So that's right, it's 17 over 4. That's an improper fraction, and of course 4 goes into 17 4 times. It goes in 4 1/4 times. Okay, that's what it is as a fraction. As a decimal, that would be 4.25, but we're not getting into that. We've got videos about all that, which can be found down below this one, I tell you. So, if you're asked to show that as an integer, that is your answer. Now, let's see if I can explain this just a little bit better. Think about it. Negative 17 being divided by negative 4. 4 negative 4s can go into negative 17, can't they? With obviously that quarter left over. And I hope I've made that plain for you. And we now flip the page over and go to another example. And this is the next example. Okay, okay. Hopefully we're starting to get the hang of this now. Question 1. Negative 36 divided by negative 12 divided by negative 3. The first thing you ask yourself is, how many negatives are we looking at? We're looking at 1, 2, and 3. So, will we have a positive answer at the end or a negative answer? We will have a negative answer because we are dividing by 3 lots of negatives. It's an odd selection. Remember, if it was 4, it would be even. If it was 5, it would be odd. If it was 6, it would be even. And so on and so forth. Odd numbers, it's negative. Even numbers, even amount of numbers being divided, it is positive. I hope that isn't too confusing. Right, we're going to try and do this in our heads, this one here, without going into the improper fractions. 36, negative 36 divided by negative 12. Right, we know that is going to be positive 3 at that point, isn't it? Okay. Now your positive 3 is being divided by a negative 3. 3 at that point is being divided by a negative 3. Can you work out the answer there? It's negative 1, isn't it? Okay? And think about it. 3 negative 12s go into negative 36. And if it's being divided by another negative, it's going to show as a negative. Negative 1 is your answer. (72) divided by negative 4. We've got a positive number here being divided by a negative. Simple case of asking how many times does 4 go into 72? It's 18, isn't it? Now, is that shown as a positive or a negative? It's shown as a negative, because remember, it's an odd number. 1 is odd, okay? 72 being divided by negative 4, it goes in 18 times. And then we could have done the multiplication bit here as well, of course. But that is going to show as a negative number. Alright? Quite a slightly easier one down here. Negative 1 being divided by negative 2, being divided by negative 5, multiplied by 20. 1, 2, 3 negatives, so we know that we're going to get a negative answer at this point here. and that negative answer is going to be multiplied by 20. Right, I'll let you try and work that one out. Right, as you try and work that one out there, I will magically disappear. Abracadabra, disappear! Ooh, I felt all faint there. Right, I have got the answer for you. Long, but answer. I've got it rewritten for you. Now, pick that one. I'm back. I picked that one because it is a bit tricky, isn't it? Because look at this. You're asking yourself, what is -1 divided by -2? You go, huh? -2 doesn't go into -1, does it? And then you're saying, then you got to divide that by +5, then multiply it by 20. Oh my goodness gracious me, this is really complicated looking, isn't it? Well, actually it isn't. This is where our old friend the multiplication comes in, you see, to work this out. The first part of the equation always stays the same. -1 is equivalent to -1/1 as a fraction. Now do you remember what to do here? You're absolutely right. -2 becomes -1/2 when being multiplied. Remember that you can get to the same answer with multiplication as you can with division. That is how you can do this, you see. We are then dividing by +5. And where does that go? Where does the 5 go here? Exactly there, because we are flipping them over, you see. You know, if we hadn't flipped them over, it would be -2/1, or it would be 5/1. But we've got to flip it over to get to the answer, and we're multiplying the whole shebang by 20. So -1 times -1, a negative times a negative, remember, is a positive. -1 times -1 is 1. Alright? 1 times 1 is, yeah, you got it, 1. Let's put that down there. Okay. Then you're asking yourself, what is 1 times 2? It is 2. And what is 2 times 5? It is 10. Then you're multiplying that. Oops. We can't flip this over, you see, because we're not dividing. We're multiplying that by 20, and 20 times 1 is 20. 20/10. So the answer to that, 10 goes into 20 twice. Answer to that is 2. As an integer. -1 times -1/2 multiplied by 1/5 multiplied by 20 is 2. And that actually makes perfect sense when you think about it. Let's put this as a fraction. Remember what we're doing here? That's right. So it's negative 78 divided by 4 multiplied by. See, it's now we're multiplying. To explain this a bit better, we don't have to flip anything over here, okay? So this is 24 over 1, okay? That stays the same, okay? We're not changing anything there. Multiplication stays the same, so it's 24 over 1. So it's negative 78 times 1. We know that's going to be negative 78. And that's got to be multiplied by 24. And we will use a calculator for that one. And gives us an incredible answer. Of 1872, but you knew it was going to be large, didn't you? We're dealing with big numbers in. And down the bottom, 1 times 4 is 4. 4 times 1 is 4. So then, let's see, we've got 1872 over 4. So we'll see what that is as an integer. It is minus 468. It's minus 468 because we started off with negative 78 being multiplied by a positive, and a negative times a positive is a negative, and that was times another positive. That gives us our answer, negative 78. This is the sum here, okay, to stop us getting confused. Negative 78 divided by 4 multiplied by 24. Now let's see if we can actually do this without doing all the sums down here. So we know that negative 78 divided by 4, that's going to show us a negative. So we'll type in 78 divided by 4. You see that is showing as a decimal, 19.5. Let's multiply that by 24 and see if we get the answer that we got down the bottom there. And indeed we do, 468. Which proves that we have done that. Sorry, minus 468. Right, we have done it correctly now. You'll be glad to hear that. Now we're coming just about to the end of the show here. Okay, now this is an interesting one here, isn't it? Now, your teacher or I have asked you to tell me what is 8,491 as being divided by 0.4 as an integer. Where do we start with this one here? Right, well, the first place we start is by putting a decimal point there and a couple of trailing zeros. So we've got both figures now showing as a decimal. Now, you cannot have the divisor as a decimal. It doesn't work, so you've got to move that one place over, move that decimal point one place over, and what we do to the divisor, we have to do to the dividend as well. So this point is getting moved one place over as well, and it goes smack bang right up there, okay? And this here is treated like a normal division problem, and you're asking yourself, how many times does 4 go into 8,491? Right, well, we have already worked it out. Now, long division is shown in videos down there, so we're just going to give you an answer here. That is the answer. 0.4 goes into 8,491, 21,227.5 times. So to show that as an integer, there is your answer. 0.4 goes into 8,491, 21,227 times. You can forget all about the 0.5 because, as I explained earlier, 0.5 is not an integer. Okay, I really hope that was of some help to you. There was probably no help at all, was it? Bye-bye.